Okay, so the theorem about Fourier series is that if f is a function so that both the function and its derivative are piecewise continuous, then the Fourier series is going to converge to f everywhere where f is continuous. And if f is not continuous at c, it's just going to average the left and right endpoint, the left and right limits. So the Fourier series converges to the left limit plus the right limit over 2. All right, notice that we don't have to worry about things like an interval of convergence, because as long as f is continuous at this point, we're going to have convergence. And also, we have very weak restrictions on what kinds of functions f and the derivative of f have to be, right? So the point is that you can calculate Fourier series for lots and lots of functions f, way more than for Taylor series, because all we need is this condition about piecewise continuity for our original function and just the first derivative. So if we want to use Taylor series, then we need that f is infinitely differentiable. If it is on a minus r to a plus r, we have an interval of convergence, and we can only hope to write down a Taylor series on intervals where all of our derivatives exist. We have an interval of convergence that we have to worry about. And even if we have that our function has, even if we know that we have an interval of convergence, it doesn't necessarily mean that that the Taylor series has to converge to the value of the function. So Taylor series are definitely a powerful tool, and they're awesome because you can do things like differentiating and integrating, which you can't do for Fourier series. But we also need a lot of information about f, and even if we have this information, we may not be able to build a Taylor series that's very useful. In contrast, for Fourier series, we lose all of this differentiation tooling, so like we can't take derivatives of Fourier series and expect to get the derivative of our function f, but we do have that we can build Fourier series for very general functions f with few restrictions, and we always have some convergence. All right, so this is the short summary of Fourier series. You will see these again in future classes. This isn't a formal part of the course, but it is something that we've spent a lot of time building up what it means to have a series. So I think this is a good time to talk about Fourier series.